Howdy, AP PreCal. It is Ms. Kosh. I am going to do the notes for 3.7 from Mr. Passwater. I don't remember if I did them last year or not. It all starts to blur. But this is, I'm kind of jumping around right now on my YouTube channel because my kids are currently covering this. But I may go back and make additional videos. Anyway, hang tight and we'll see what happens. Okay, so in previous units, we've looked at different methods to construct models of various functions. Now we will apply those same techniques to create function models for sinusoidal functions. Isn't that a fun word? Sinusoidal. We already have seen that sinusoidal functions can be written in this form or a similar form with cosine. To construct a model, we will need to connect information that is given verbally, graphically, numerically, and algebraically, okay, to the properties of sinusoidal graph. So here we go. There may tell us the graph is given, what is the period? Okay, so when I look at this, I want to see how long does it take it to do everything it's going to do? It took it 2 units. The next one, let G be a sinusoidal function. It's, this now tells us our period is pi, and sure enough, that looks like pi. And then it shifted down 1, sure enough, there's the midline. Which of the following could represent the constant c? So it's cosine, which starts at the very top or the very bottom. Now, one way to write this is that you could call this equation y equals, you could call it negative cosine of 2x minus 1, but they left that positive, so you can't use that. So what we want to do is we have to start at the top, so plus c means that we can either, we can either shift it left or right pi over 2, and luckily that's the only answer that makes any sense. So plus pi over 2 means that we would shift it to here. So it would be looking at this little piece. Okay, let's keep going. My kids, those two should have been easy for y'all at this point in the year. So hopefully that's the case. I think I remember struggling with this one last year. The yo-yo is attached to a 30-inch long string or rotating around at a constant rate. The figure provides representation of the yo-yo in the direction of the rotation indicated. So it's going this way. After a time t equals 0, the yo-yo begins to rotate. The yo-yo is at the start position. Here it is. At time 5, the yo-yo has completed 20 rotations. Okay, so if in 5 seconds it does 20, in 1 second it does 4, so it's 4 rotations per second. And that is the frequency of the graph. Okay, so that tells us how much have I accomplished in 1 unit of time? Well, I did 4 rotations. What's its period? Its period is 1/4. It takes it 1/4 of a second to do everything it's going to do. A sinusoidal function is used to model which of the following functions is appropriate model? Notice all of them have the same amplitude, so that is not something, is this in focus? That's not something we need to think about. And they have no shift left or right, they have no shift up or down. All we're looking at is what would the b value be? Well, we just said that that 1/4 is the period. 1/4 of a second is the period. So it's 2 pi over b is equal to 1/4. So I can cross multiply. I see 8 pi is equal to b. Okie dokie. And there's my 8 pi. This must not have been the one that caused me trouble last year, or if so, I'm smarter this year. that wasn't so bad. I'm sorry. Okay, clock is mounted on the wall. Point P is looking at the tip of the minute hand of the clock. Oh, we just did one like that in my 3.1 video. The function h represents the height of point P from the ground. Okay. H of 0 equals 70 and h of 30. Okay, this represents a maximum value and a minimum value respectively. What are the values of, okay. What in the heck is happening? We're at 0, 70, and then we're at 30, 52. Notice they didn't tell me if I'm going, they said that they're a max and min. They didn't tell me if it's like this, or let's see if I can find, or if it's something like we go up and down and up and down and up and down and up and down. We don't know. But what we do know is that no matter what the period is, the amplitude and the midline will be the same, and that are already set, and they don't depend on the period. Okay, so the amplitude, let's draw this again because that got messy. We're going from here to here, let's just say. So this is 0, 70, this is 30, 52. That total distance, 8 gets me to 60, so 18. So this they're 18 apart, which means that the midline is going to be 9 units above. So if I add 9 to this, I get y equals 61. Add 9 units to that, and I get this right here. So what is my A value? My A value is equal to 9. It's the amplitude. Does it have to be? Well, they told me it was. Does it tell me it's positive? I might prefer to say that the absolute value of A equals 9, but anyway, it'll probably show up in multiple choice. And then this midline gives us our D value. So our D value is equal to 61. And I think there's one more page. Here we go. The average monthly temperature in degrees Fahrenheit for a town in central Indiana, all right, can be modeled by the sinusoidal function this. For 1 to 12, I don't know why I said 12 months. Based on the model, which of the following is true? The maximum average monthly temperature is 61.2 degrees Fahrenheit. No, that's the midline. So it's not going to be the maximum. The maximum average monthly temperature occurs at m equals 1 month. Okay, if I plug in 1, well, let's come back and check that one in a second. Let's see if we can eliminate more. The minimum average temperature is 35.5. Well, 61.2, I'm too lazy to do addition and subtraction right now. 61. That's not a 6. 61.2 minus 25.7. The lowest we're going to go is 35.5. So the minimum average monthly temperature, so which of the following is true? That's true. Let's go back and verify why the others are false. The minimum average monthly temperature occurs at, okay, so they want us to plug these things in. Let's go ahead and do that. So T of 1 would equal, okay, I'm sorry. I'm trying to do this officially for you. I would probably do it with a little more shorthand. Plus, I ran out of space, plus the 61.2. If I were doing it myself. Okay, here's what we know. This is -3, so this is sine of negative pi over 2. So negative 3 over 6 is negative pi over 2. Sine of negative pi over 2 is equal to -1. So if I plug this in, I have, this is as low as it's going to go. The maximum occurs there? No, the minimum does. That's why that one was wrong. Okay, plug in 7. Let's see, 7 minus, this is 3, so this gives me a sine of pi over 2. I should have just done this the first time. Sine of pi over 2, that's its maximum, and it says minimum. No, it's wrong. Super. Okay, the function gives the number of nighttime hours on the first day of a given month. I assume January to whatever. The table gives values of n selected, okay, a sinusoidal regression with, 16 iterations. We struggled with this last year. I think this is a matter of setting up your calculator, but I use Casio, and I'm not sure how to change iterations. So my kids use a Casio, and we'll all be good. The TI, I think you can change how many iterations you have, and basically what that means is that the calculator will, okay, I struggled with this last year. What we do is we're putting in points that kind of give us the sine curve. All of a sudden they go like this or whatever, and so we're looking at those values. 16 iterations means the calculator then does it 16 more times. You only enter it once, but it does it 16 more times, and then it curves out the equation, I think. If you know better than me, let me know below or give me a link to something that'll talk about this. I think it's a difference between Casio and TI where this kind of comes into play. A sinusoidal regression with 16 iterations is used to model the data. This is absolutely positively, is this a calculator question? Okay, what did they ask? What is the maximum number of nighttime hours predicted by the sinusoidal model? Okay. I think we do need to use our calculator here. And I'm going to use the Casio because the only TIs that I have are probably older than what's around. Oh, that's not where I want to go. Delete. I'm not sure what you were looking at there. So my apologies. Here we go. We're in statistics. I'm going to go in and enter in this data. What am I doing? I should have just cleared my calculator. I apologize. But I can delete all. Yes. I can delete all. Oh, and that's not every number here. Oh, okay, delete all. I didn't do it. Delete all. Yes, there we go. Oh my goodness, that was embarrassing. 1, 3, 4, 6, 7, 8, 11, 12 are the numbers that they gave us. 11.4, 9.7. Hopefully I'm typing this in to the calculator correctly is what I was trying to say. 5, 6.2. If I am wrong, tell me down below. I'm kind of in a hurry, so there we go. Oh, something's wrong. Okay, let's see. 1 should be with 11.4. 3 should be with 9.7. 4 should be with 8.2. 6 should, no, there should be a 6. 6 should be with 5.2. 7 should be with 5. 8 should be with 6.2. Did y'all catch this mistake before I did? Good for you. Very smart. Okay. Now I can graph that. Here's my graph. I can calculate the sign regression. And I can, well, let's copy it into here. Enter. Draw. There it goes. Okay, so what were they saying? With a sinusoidal regression with 16 iterations used to model this data, what is the maximum number of nighttime hours predicted? Okay, so when I look at this would be how I would do this problem. I would go back to graph and I would turn this on. I have to hit select, I hit draw, and now I'm going to G-solve and find the max. And so the maximum number of hours, this is when it happened the first time, is 11.33. Is that a reasonable answer? Oh, I guess I should look it up. Maximum number of nighttime hours predicted by the sinusoidal. Do we round up or down? Do you have an answer for me? No, I'm just kidding. 11? I think the problem is the 16 iterations, and I don't know how to change that on my Casio. I may go play with this for a second and see if I can figure it out. This rounds officially to 11, which matches that answer, but I'm not sure what he intended to be the answer. But let's move on. All right. If I'm not happy with this answer, I'll make another video and link it down below. So in the meantime, like, subscribe, comment, do good math to a good answer, and go practice.